Hello viewers, in today's session we are going to discuss another important problem from limits and continuity of functions. And in this session we are going to discuss this important and conceptual problem related to finding out the points of discontinuity of this function f of x, which is greatest integer of sin x plus 1 when x belongs to the closed interval, that is 0 comma 2 pi, right? So here we'll see how we can find out all the points of discontinuity of this greatest integer function, where we have greatest integer of sin x plus 1 and x lies between 0 and 2 pi, including the endpoints 0 and 2 pi. So let us start. So to solve this problem, we have to make use of a simple concept, that is the greatest integer function is a discontinuous function at all integer points, right? Suppose we have a function, say greatest integer of say f of x, right? Now this function greatest integer of f of x is discontinuous at all those points for which f of x is equal to k, where k belongs to the set of integers, right? So if we have a function of this form, that is greatest integer of f of x, then this function is discontinuous at all those points where f of x takes an integer value, that is f of x is equal to k, where k belongs to the set of integers, right? So this concept will be utilized to solve this problem. So now let us take this function, that is sin x plus 1 as g of x, right? Because here we are already we have used this notation f of x. So let us take this function sin x plus 1 as g of x. So f of x is now equal to greatest integer of g of x, and we have just discussed that this function is discontinuous at all those points for which f of x is equal to k. So here this function f of x is discontinuous for all values of x for which g of x is equal to some integer, that is k. So now g of x is 1 plus sin x, and this is equal to k. So we can take sin x is equal to k minus 1, right? Now see, we know that the values of sin x, it lies between minus 1 and 1, right? So the range of sin of x is from minus 1 to 1. So we'll make use of this inequality. So sin x, it lies between minus 1 and 1, including minus 1 and 1. So here taking sin x is equal to k minus 1, we have minus 1, k minus 1, and here we have 1. Now let us solve this inequality. So adding 1 throughout, we have minus 1 plus 1, and here we have k minus 1 plus 1, and here we have 1 plus 1. So this is 0, and here we have k, and here we have 1 plus 1, 2. So this inequality suggests that the integer k, it takes the values 0, 1 and 2, because between 0 and 2 we have the integer 1. So here we have 0, here we have 1, and here we have 2. So k lies between 0 and 2, including 0 and 2, right? So the required values of k are 0, 1 and 2. So now to get the values of x for which this function f of x is discontinuous, we'll make use of the values of k. So let us first take k is equal to 0, in this equation, right? So we have 1 plus sine x is equal to 0. So from here we have sine x is equal to 0 minus 1, that is minus 1. Now sine x is equal to minus 1 gives us x is equal to 3 pi by 2, right? Because for 270 degrees or 3 pi by 2, sine x is equal to minus 1. So this is our first point where this function 1 plus greatest integer of 1 plus sine x is discontinuous. Now let us take k is equal to 1. So when we take k is equal to 1, we have the equation 1 plus sine x is equal to 1. Now sine x is equal to 1 minus 1, that is 0. So sine x is equal to 0 gives us x is equal to 0, and here we have pi, and then we can also write 2 pi, because we know that the solutions of this trigonometric equation, that is sine x is equal to 0, gives us x is equal to n pi, where n belongs to the set of integers. Since we have to restrict ourselves to this interval only, so here we have the values of n is equal to 0, then we have x is equal to 0. When n is 1, then we have x is equal to pi, and when n is 2, then we have x is equal to 2 pi. Now let us take k is equal to 2. So when k is equal to 2, here we have 1 plus sine x is equal to 2. Now solving this equation, sine x is equal to 2 minus 1, sine x is equal to 1, right? And sine x is equal to 1, it gives us x is equal to pi by 2, because sine 90 degrees is equal to 1. So now from this discussion, we have seen that when k is equal to 0, then 1 plus sine x is equal to 0. This equation gives us x is equal to 3 pi by 2. When k is equal to 1, then this equation 1 plus sine x is equal to 1. It gives us three values of x, that is 0, pi and 2 pi. And when k is equal to 2, then this equation 1 plus sine x is equal to 2 gives us this value, that is x is equal to pi by 2, right? So now combining all these values of x, we can see that this function f of x is discontinuous at these points, that is 0, then we have pi by 2, then we have pi, and then we have 3 pi by 2, and then we have 2 pi, right? So there are 5 points between these two values, including 0 and 2 pi. So when x belongs to this closed interval 0 comma 2 pi, then we have 5 points at which this function f of x, that is greatest integer of sine x plus 1, is discontinuous.